projects. In this video, we are going to explain about the project entitled as Developing a Transparent Anemia Prediction Model Empowered with Explainable Artificial Intelligence. Before getting into the video, let me give you a brief explanation. Anemia is a major global health concern that affects millions of individuals, particularly women and children. Due to nutritional deficiency, chronic disease, and genetic factors, early detection and accurate prediction of anemia can significantly improve patient outcomes and reduces healthcare burdens. This focuses on developing a transparent anemia prediction model that leverages explainable artificial intelligence techniques to ensure both accuracy and interpretability. Coming to the existing system, the existing anemia prediction system rely on convolutional, statistical, and machine learning models using clinical and laboratory data. However, they face issues like limited accuracy, lack of transparency, and poor adaptability. Most models act like black boxes, offering prediction without explaining contributing factors. They also require extensive tests and fail to provide personalized clinical insights. Hence, a transparent explainable AI model is needed to improve prediction and interpretability. Coming to the proposed system or base paper work, the proposed model integrates the advanced machine learning algorithms with medical data such as hemoglobin levels, red blood cells index, and demographic information to predict anemia risk efficiently. Unlike traditional black box AI system, this model emphasizes transparency and explainability, allowing healthcare professionals to understand how specific feature contributes to the prediction outcomes. Techniques such as shape and line and feature important visualization are used to interpret the model's decisions clearly. The project uses the anemia dataset from Kaggle. Key features including gender, hemoglobin, MCV, MCH, and MCHC. Each record is labeled as anemic and non-anemic for classification. The dataset supports accurate model training and evaluation for anemia prediction. Coming to the novelty or extension or improvement or enhancement of the project. As an extension of the project, we implemented the hybrid model combines random forest, gradient boost, and SVM using a voting classifier to enhance accuracy and reliability. Each model is trained independently and their predictions are aggregated based on weighted consigns. This approach leverages the strength of all algorithms, improving prediction performance and clinical decision support. The system incorporates explainable AI techniques such as line and sharp to make the model's prediction more transparent. This tool helps users understand how each feature contributes to a particular prediction, increasing trust and interpretability of the system. Additionally, a Flask-based frontend was developed to allow users to interact with the system easily. Through this interface, user can input their data and view predictions in a user-friendly way. To maintain privacy and security, user authentication was added, ensuring that only authorized users can access the system while enabling particular testing of its functionality. Coming to the flow of the work, firstly, we need to import the packages, which means we need to load the necessary Python libraries like Pandas, NumPy, Scikit-learn, Matplotlib, Seaborn, and XAI tools. Next, exploring the dataset. It loads and inspects the anemia dataset for structures, types, and initial insights. Then, data pre-processing. In this, we clean the dataset by removing the null values and duplicate entries. Next, data visualization. Data visualization is a graphical representation of the data using visual elements like chart, graphs, maps, infographics, and dashboards. Then, splitting the data set. Splitting is a process of dividing the data into training and testing sets to train a model and evaluate its performances. Then, we need to normalize the data. In this, we standardize feature values using the standard scalar for model efficiency. Then, building the classification model. Classification is a process of training an algorithm to categorize data into predefined classes or labels. Then next, we need to train the model. It fit all the classification models on the training data set. Then comparing the models. Evaluate models using metrics like accuracy, precision, recall, F1 score, sensitivity, specificity, miss rate, fallout, LR positive, LR negative, and negative predictive values. Next, we need to compare the graph. It visualizes the model performance across metrics using bar or line graphs. Then we need to save the best model. In this, the highest performing model is saved by using pickle or joblet. Next, explainable AI visualization. Using Lime and Sharp to interpret model predictions and feature importance. Then, we built a front-end interface using Flask framework with registration and login functionalities supported by SQL database. User also provides the input by entering the required feature values. Then pre-processing. The input data is pre-processed in the same way as the training data for accuracy prediction. The trained machine learning model is used for prediction. The final prediction is displayed to the user through the front-end interface. The algorithm used in the project are decision tree, k-nearest neighbor, support vector machine, gradient boost, multi-layer perceptron, and as an extension we have used voting classifier. Coming to the requirements, we have both hardware and software requirements. Hardware requirements: operating systems, Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements are application framework is Python, front-end framework is Flask, backend Jupyter Notebook, database SQL Library. Technologies used to build the front-end Flask framework are HTML, CSS, JavaScript, and Bootstrap. To execute this project, first we need to open the project code folder, which contains the project source code files. Static folder. This folder consists of the files related to CSS, JavaScript, and Bootstrap. Template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and etc., which represents different pages of the website. Next, app.py file. This py file contains the information related to the front-end logic. It could include code written in Python that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. These are model files which contain algorithm information which will be loaded into the project code during the runtime. Then notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows user to write and execute code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store the user's information. Now, coming to the execution of the project. Firstly, you need to copy the path of the code folder from the address bar of the file explorer. Then, open Anaconda prompt. Use the cd command followed by a space and then paste the copied path. This command is used to change the current direction of the code's path. Compile the app file using the command python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, The Flask framework will host the application locally at the default address. Now, copy the link provided by the framework and paste it into any web browser. I prefer in the Chrome. So, this is the web page of the project, which is displayed in the browser. This is developed by using Flask framework with the technologies like HTML, CSS, JavaScript, and Bootstrap. Here, we have home button, login button, and sign up button. So now click on sign up button and give the details to sign up, like username, your full name, mail ID, contact number, and a secure password. Then click on Join Anaemia AI. Then to log in, we need to give the username and password. Click on Access to Anaemia AI. Now, we have logged in successfully and redirected to Anaemia detection page. In this page, you can see the prediction, visualization, notebook, and logout. Firstly, we need to click on the button Prediction. So, these are the parameters which we need to give as an input, like gender, hemoglobin, MCH, MCHC, MCV. So first, let me give the inputs like male, hemoglobin levels are 14.9, MCH value is 22.7, MCHC value is 29.1, MCV value is 83.7. Then click on Analyze with AI. Here, when we click on Analyze with AI, the given data will be pre-processed and the final outcome will be displayed. Like it is non-anemic. The confidence level is 98.8. Like no anemia was detected for the given input. So here we have the other parameters like possible causes. Then recommendations like we need to maintain the health diet, regular exercise, annual checkups, and prevent care. Important precautions are like medical disclaimer, professional consultation, timely action, monitor changes, and medication. And we also have the additional information like hemoglobin analysis, AI model, confidence score, and data privacy. Then let me give you another input for anemic predictions. Like the gender will be female, hemoglobin level is 9, MCH value is 21.5, MCHC value is 29.6, MCV value is 71.2. And now click on with Analyze with AI. When you start clicking on Analyze with AI, the given data will be pre-processed and the final outcome will be displayed. Like for the given input, it is predicted as anemia. The confidence level is 96.2, which means the given input has been detected as anemia detection. And the possible causes are like iron deficiency, vitamin B12 deficiency, float deficiency, chronic disease, blood loss, and genetic factors. And the recommendations are you need to consult a healthcare provider, blood test, dietary changes, vitamin supplements, lifestyle, and follow up. We also have the important precautions like medical disclaimer, professional consultation, timely action, monitor change, and medication. We also have the additional information for this like hematological analysis, an AI model, confidence score, and data privacy. Then click on visualization. Here you can see the visualization which has been done in the project like value count results, box plot of multiple numerical columns, and future correlation heat map with values. We also have accuracy like in the x-axis we mention the algorithms and the y-axis is known as for accuracy. Precision, in x-axis we have the algorithms and in y-axis we have the precision values. Same way, we have recall, F1 score, sensitivity, specificity, miss rate, fallout, LR positive, LR negative, NPV, and explainable AI sharp. This is how we need to analyze. Then click on log out. The project has successfully developed a transparent anemia prediction model using explainable AI for accurate and interpretable results. It enhances clinical trust, improves diagnostic accuracy, and supports better health decision making. This is all about your project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.